Okay, so here we are again. And what I'm doing is I've got this little box that I use for making drum sounds. Um, and I can make all the sounds of a full drum set. And I'm not doing it well with one hand, but I do, and I've been using it for I don't know, about a year almost. And it's a little worse for wear. It was a cardboard box, and I put AUPD dust and glue, Elmer's glue, on it, um, and then covered it with what they call aluminum foil, but I got mine down at the dollar store, and it's not actually aluminum, it's AUPD. Um, and has a very high melting point and makes rainbows because it's made out of this dust right here, this kind of dust. Um, and what I'm about to do is mix up some borax in there, and I'm gonna try. There it is. Okay. So that's good. About a quarter of a kilo of 250 grams of borax, which is a sodium boron mixture of stuff, like for laundry. That's what that's for, laundry, borax. You buy it from Amazon, it's a couple of dollars, not expensive. And you mix it up. And I've been using these pans for a few years, so there's other stuff in there from my previous attempts. There's some now. Look at that. All right. So, and I just break it up because it kind of recycles when I use the heat on it. The borax melts up through the metal and out the flame and blows back down into the stuff and turns into this and what they call soda ash. Um, and so I get rid of most of the little balls when they get too hard. Um, but I'll break it up too because it's recyclable. It's not going anywhere. It's just passing through the metal that I'm working with as a flux, and it drags this dust with it. But if you look, the dust is really, really, really fine. And in fact, it's submicroscopic, the particles of dust. Um, and they're so fine that when the borax melts, it just follows along with the borax and moves into the metal. So my pan here is not an aluminum pan; it's an AUPD pan because I moved that metal into and it replaced the aluminum. Okay, but today that's not what we're doing. Today what we're doing is taking my box and you will notice that these are the same thing, right? And I get my essential oil in this, in these guys, and it's just a cardboard box, right? It's just a cardboard box, and now this has some coils of wire inside, and I'll open it up when I have two hands. But See the difference? Is it? This sounds like a cardboard box. This sounds like a piece of metal. And it's just aluminum foil, honest to goodness. Aluminum foil. What's sold is aluminum foil at the dollar store anyway. And it is a UPD. I checked. Um, and they use it because it's a lot cheaper to make than aluminum. This stuff is volcanic ash and pretty much covers the planet. Um, and the whiter stuff has a higher palladium content. The more gold stuff has a higher platinum content. So what we're going to do is open this guy up. Maybe if I back out a little bit, see what I'm doing. I'm just getting it all over the inside of the box. And of course, at the same time, I'm also getting it all over the outside of the box. And now I'm going to add Elmer's glue. To the inside of the box to start with. And, you know, this is really hard one-handed, man. My phone holder thing gummy is lost. So I'm one-handed here. Okay, and it's just spreading it around. There's nothing complicated about it. We're making bioplastic. Hey, Joe, would you get me that other bottle of Elmer's over there on the floor, please?
Are you still recording?
Yeah, I sure am. I'm. Yeah, yeah. You're gonna have to open the thing and then put it right there. Good old. You know what? No, you can put that right there.
Paper cup?
That plate right there. Empty. Okay, and pour the stuff in. Por favor.
Much?
Fill it up, babe. That's good. Okay. we're not shy with this stuff. It's not like expensive, you know. And it's absolutely non toxic, which is guaranteed by 50 bazillion kids in schools everywhere, right? Everywhere, man. Good stuff, Elmer's glue. And we're going to soak this so that it goes into the cardboard and it becomes, see, because I put the flux in it, when this melts and the box gets soft, it drags that dust with it into the box, just like when I heat up my metal. And so what I end up with is like a concrete, a plastic concrete that can be as hard as concrete, literally as hard as concrete. Um, and it rings like a bell because it's so hard. And I can sand it and paint it, and I could dye it different colors, you know, with the glue just by using like food color or something. Um, and the Chinese make what they call lacquer furniture out of the same kind of stuff. They probably didn't use Elmer's glue, but it's the same stuff. It's a cellulose-based glue that is literally non-toxic. I mean, you can eat it. Cellulose is like the inside of plants, um, and it's water soluble. Okay, but when you make it like this, it gets really really hard, um, and it's still water soluble. If I don't like what I make, I can put water on it and make it go away. That's kind of cool. But other than that, if I want to make it waterproof, I can spray it with shellac, for one thing, which is also an organic plastic made from bamboo. It's the stuff that makes bamboo hard. Um, and so the plastic becomes shiny and water soluble. You know, you sand it and finish it like a piece of furniture. And I've got a piece of dresser over there that my wife dragged in the door a few months back. She says, I think it's made out of metal because it gets so damn heavy. This stuff is platinum and palladium. Um, Palladium is about the same specific gravity, the same weight per volume as silver, about the same, about 10, 9 or 10. Um, Platinum is 22, 21.9, I think, um, times more dense than water. So it's heavy. It's really heavy. Um, it's also really strong because when it goes into the box here, the cardboard, it creates covalent bonds through the glue. And that box that I've been pounding on, and I have been pounding on it now, and I use it as a drum set on a pretty much a daily basis. And it makes beautiful music. I'm getting really good at it. Um, and it's bioplastic. it rings like a bell. And it's held up to being pounded on with sticks and my hands, and and plus, there's stuff inside of it too, right? Um, one of the things that makes it ring is I've got these coils of AUPD wire in there, and they bounce into each other a little bit. But that's what part of what makes it ring. Um, that's not what makes it ring. I mean, you can pour those out. That's what makes bioplastic. Um, when I just cover it with tinfoil like this, the tinfoil latches on to that glue and participates in those double covalent bonds. Um, and that's why it's staying in place like it is, because it's welded on there basically with my bioplastic, and it becomes waterproof and flame proof. You can't burn it. I can hit it with my propane torch. MAP gas burns at 1300 degrees, and it just sits there. Gets a little dark where the flame was, but it doesn't burn. And it's as strong as concrete and as light as a piece of cardboard. Isn't that far out?